Alright, so we are doing temperature sensing using Arduino, and this time we have used TMP36. Last time we were using microbit, but the problem with microbit and temperature sensing is the limit to which it can sense, which is just 50 degrees. So when you want to do more than 50 degrees, you will have to use this sensor called TMP36. Now TMP36 has 3 pins, as you can see. It's power, it's V out and ground. Power will go to 5 volt, and you can color it red as well because we are giving it some voltage. V out is the pin from which you get the values of the temperature. So the sensor doesn't directly give you temperature, but there is a small calculation you can do. Let's leave it green. To calculate or convert whatever values TMP gives you to temperature. And ground goes to ground. So if you want to see how, okay, I've just coded it over here. Maybe I'll just remove the code for you now. Okay, so whenever you begin with a sensor, I think the right thing to do would be to use print serial monitor to know what is it that the sensor is giving you. And you have something called read temperature sensor. Now ideally you would just go for read analog pin, but since you know there's a lot of mathematical calculation behind it and it is being done for you by this block, let's take that block. Once you start the simulation, you will start seeing the values being printed to serial monitor, and you can change the values from here to see the variation as well. If you want to see the calculation that goes behind this block, I would request you to check blocks plus text, and you can see there's a mathematical formula that is being used to convert whatever values you get from TMP36 to temperatures. Let's go back to blocks. Now we want to actually, so since this is a very big block, we are going to use a variable. I've made a variable called temp just in case, so I show you how to make a variable. I'm going to delete it for now. Just click on create variable, write down your chosen one, and there you go. So I'm just going to remove this here and move it like this. Way better. So we are just setting the temperature to this in the very beginning, and we are using it. We need a lot of if blocks to get our logic right. So let's go for if blocks, go to math. We know we have a variable. So let's go to 7. So our values are 75 and 105. Less than 75, it has to be green. So before we decide what has to be green, we need an RGB LED over here. So I have an RGB LED over here. Let's quickly connect it. Cathode obviously goes to ground, and that's the easiest connection that we know of. I'm just going to leave it like this. We can also add a resistor. I think I would just add one resistor over here, the value and ground. We normally have the resistor at 100 ohms, so let's try that first. Yeah, pretty much like this, and let's color it black. Yeah, that's a little better. Yeah, we have red, and I'm connecting this to 9, 10 and 11 because RGB values can take analog answers, and I think it's always nice to give right values. So let's take it to 9, 10 and 11. That is PWM pins, right? So I'm going to choose red for 11 and just color it red so I remember. Blue for 10. I'm just doing it in the order, there's no particular reason. And green for 9. Let's give it green. And we have our LED that is connected. Let's go back to code. So yeah, so if it is less than 75, we want our blue LED to light up. So we simply go over here and select the pin number 10 because blue is connected to 10, and give it to 55. We want the other to shut off at that point, so we are going to use 9 to 0 and 11 to 0. And that's our first if condition. I always recommend to duplicate blocks so that you don't have to drag and drop and it becomes a little easier. Next condition is greater than 11, greater than equal to 105. and here is when you want 11 pin to light up, and so we are just going to change this to 255 and we are going to change this to 0. Again, duplicate the blocks, put them below. This time we have the end condition where we have it either less than 105 or greater than 75. And this time we want 9 pin to light up and other two to remain as 0. So that's our code. Let's start the simulation. As you can see right now, the LED broke because we are passing way too much current than it can handle. So our resistor value is wrong. So let's just amp it up a bit. Go for 500 ohms. And then, perfectly reasonable color. Move the LED and you can see this time it is what, 79, which lies between 75 and 105. And you can see it's green. Again, a little higher, and there you go, you can see red. And that's your basic temperature indicator using TMP36. Here is the code for you to glance. It's basic if else condition. Reading temperature is where you get from input, and that's it.